Hi, you guys. We're going to go ahead and start Skill 15 Intro to Logarithms. So the first few slides are going to be notes walking through um, what a log is and how we get it. So make sure you have your notes out ready to go. We learned about this earlier. Skill 1, or not skill 1, I think it was maybe 2, 3, 4, inverse function. The definition of an inverse is to switch the x and the y, or in other words, the input and the output. So we have exponential functions, which is what we just got done working with, y equals 2 to the x. This is what that would look like. This is what the graph would look like. If we switch that, we'd have x equals 2 to the y. And this is how we would fill in the chart, and the graph would look like this. So all of our x's became y's, and all of our y's became x's. The name of the inverse function that we just talked about to an exponential function is called a logarithm. When we write the inverse as x equals 2y, it is not helpful because y is not isolated. In order to write y as isolated, we write it in log form. So here is this idea that once we take the inverse, we switch the x and the y, but then we want the y by itself, so we write it in log form. We're now going to practice converting between log form and exponential form. So one way to think of it is if I have log form, 5 to the x equals 25. So the little number is the base and the equals the exponent. So let's take a second. My exponent equals log whatever my base is. So this 5 went there. The exponent went there. And I did the same thing here. If you follow along with this, go ahead and try example 1, letter B on your own. We should get -3 equals log base 4 of 1 over 64. So that's how we go from exponential form to log form. To go from log form to exponential form, I think of a loop. 2 to the 5th power equals 32. 2 to the 1/2, or 4 to the 1/2 equals 2. We're going to take some time to keep practicing this. So 2 to the 0 power equals 1. If you ever want to check it, you can do the loop and see if it looks like how 2 to the 0 equals 1. And that's what we had there. Now it wants me to write this in exponential form. So I'm going to do the same loop idea. 5 to the -2 equals that. Sometimes we have like imaginary, we need to solve it or don't know the answer. So I'm going to go ahead and put an X. And I'm going to rewrite where the box is and just put an X. There's a couple ways to think about these. I'm going to go ahead and loop it. 5 to what power is 1 over 5? I can think of it that way. And then I can write with the same bases. 1 over 5 is the same as 5 to the negative 1. And then I just know x equals negative 1. I can use the same idea over here. I'm going to convert it to exponential form. 2 to the x equals 32. If I write these with the same bases, 32 is the same as 2 to the 5th, I think. Yeah. Now that my bases are the same, I can set the exponents equal. X equals 5. So here I'd have a negative 1, and there I'd have a 5. This is a similar idea. I'm going to rewrite it over here so I can loop it. (64 to the 1/2 equals x). In other words, that's the square root of 64. Sorry, I jumped ahead of myself. And that would be 8. Okay, now that we've spent some time with logs, we're going to introduce the idea of a common log and a natural log. So we have this idea of an e, and it's Eucker's number. It's a famous irrational number, like pi, and e is about 2.718. It occurs in systems of growth exponentially, like populations or interest. What is ln or natural log? It's this idea of y equals log base e of x. We would just write that as ln of x. It's inverse with y equals e to the x. So we don't write over here ln of x is the same as log base e of x. You should see an ln button on your calculator, and it has the same other properties of any other logarithm. Common log, every log needs to have a base. If a base is not written, assume the base is 10. Is base 10. So log of x equals log base 10 of x. So if you see like log base 3, that is the same as log base 10 of 3. If you see ln of 3, that's the same log base e of 3. So our calculator also has a log button and an ln button, and we're going to start doing this in our calculator. So go ahead and in your ALEKS calculator put in log 27.3. It wants the nearest thousandth. So that's going to be 3 decimal places. So this would round to 1435. This should round to 0.973. Go ahead and make sure you know how to do that and practice that. The last thing we're going to do is write this as an exponential function. So this is log base e to the x equals y. I'm going to go ahead and loop it. E to the 9 equals x. Right, this is a log. So my base is e, and it would look like that. If you needed to check it, you could loop it. E to the y equals 2, and that's the same as what I started with.